Welcome everyone to this channel. Today I am going to cover the basics of Makefile and how you can use it for your software compilation. This is a introductory tutorial on you writing your own Makefile with a simple example. So the main purpose of using Makefiles is to automate your build process, mainly for the software projects, but you can use it for other purposes as well. Uh, the first question that you would be asking yourself is why use Makefiles in the first place. So the main motivation or the objectives of using Makefiles is automation. It automates repetitive compilation tasks. It's efficiency. It only recompiles files that have changed, so it saves you time. Organization. It organizes the build process in a clear and a structured way. Portability. It provides consistent build process across different systems. Scalability. It handles complex projects with many source files. Sometimes without Makefiles, the life will be very difficult, especially when the project contains multiple source files across different folders. So Makefiles become necessary in those use cases. In this tutorial, we will go through the following contents. First is the basic structure of a Makefile. Then what are the variables typically used? Then what are the pattern rules? What is a phony target? Some of the advanced features we will cover, and then we will wrap it up with a complete example. The basic structure. A Makefile consists of rules, and the format of the rules is as shown. There is a target given, then a colon, followed by a list of dependencies. The dependencies are separated by space. Then in the next line, there is a command. The command is always indented with a tab. It is very important to note no spaces in front of command. It has to be a single tab. So this is the structure of a rule, and the Makefile consists of a bunch of these rules. Here is an example of a simple compilation. Uh, the lines which start with hash are comments, so you can ignore them. Uh, Hello is the target, hello in blue color, colon, and then separated by hello.c. Hello.c is the dependency. So what it means is whenever there is a change in hello.c, the target will be regenerated. And the rule here is gcc hello.c minus o hello. So what it says is compile hello.c using gcc, and its output put it in the file called hello. To run this Makefile, from the command line, we will just say make hello. Since hello is a target in the Makefile, the Makefile knows what to do when the target name is given. What it will do is it will just compile hello.c and put its output in a file named hello. Next topic is variables. Uh, we can use variables in the Makefile for readability. For example, when you want to compile using GCC all the while, we can just define GCC as a variable and put it in a variable called CC. Typically, variables are put in capital letters so that it's easy to distinguish. The second variable is C flags, that is defined to be minus W all minus G. And to use the variables, we will have to put a dollar sign and enclose the variables in round brackets. It's very important. As you can see here below, this is the variable that is getting reused. So this will be replaced by GCC by the Makefile, and C flags will be replaced by minus W all minus G. So this is a Makefile, same as earlier. Now this consists of variables plus a rule. Variables make Makefiles more maintainable. Now, pattern rules. Sometimes we might use patterns to handle multiple files of the same type. For example, for all the C files, I need to create OBJs. So I don't need to mention a rule for each and every C file. What I can do is I can just create a pattern %.o colon %.c. What it means is whenever there is a C file, its corresponding OBJ target is this, and the rule for that target creation is this. So here we are using some automatic variables in this rule. One of the automatic variable is dollar with a less than sign. This means it is the first dependency in this list. This is the dependency list. So this will be the first dependency. And dollar at is the target name. So this will be the target name. So dollar at will be replaced by target name. For example, if this is hello.o and this is hello.c, the first dependency will be hello.c and minus o will be replaced, minus o target will be replaced by hello.o. So this is an example of pattern rules. Next is phony targets. So sometimes you might have the same file as the target name in the make file. So just so that the Makefile don't get confused with the file name, you define a phony target. For example, in this case, let's say I have a file named clean in the same folder and I don't want Makefile to be confused with the clean target inside the Makefile. What I will do is I will define phony as a target name inside the Makefile. So what it will do is whenever it encounters this target as clean, it will run this rule rm-f star.o hello. So if I want to use this target, I will say make clean. So even though if I have a local file by name clean, make will not get confused. Let's go to some of the advanced features. The first topic is using of automatic variables. So we have already encountered an example where two automatic variables were used. $@ is used for target name. Dollar with a followed by a less than sign is used for the first dependency in the dependency list. Dollar followed by a caret sign is used for all the dependencies in the dependency list. Dollar followed by a question mark is used for all the newer dependencies. We can also use functions in Makefiles. For example, if I want to get all the C files in the folder, I don't have to list them manually. I can simply say sources equal to dollar wildcard star.c. What it will do is it will browse the current folder from which this command is run and list all the star.c files and put them in the variable called sources. Next function, if I want to convert all the .c files to .o files, I can use this function called pat subst. This is a pattern substitute function. What it will do is it will take the input as star.c. So whatever is the name before the .c will be replaced here and create a .o. So from this list sources, it will take all the star.c files and convert them to star.o. And all this will be replaced in this variable called objs. So this is an example of how you can use functions inside Makefile. Next, we will show a complete example of a Makefile and how a simple C project can be compiled using Makefile. First, we start with variables. There is a variable defined as cc, which is defined to be gcc. This is the compilation command. Then C flags is the next variable, which is defined to be -w all -g. Next, we have all the sources, which will be picked from the current folder. All the star dots, all the C files are picked and put in the sources folder. Similarly, OBJs will be all the file names followed by .o. Target is my program. The default target is this. So my program, to build my program, the dependencies are all the OBJ files and the rule is cc followed by C flags, followed by dollar at, dollar followed by caret. If you remember, this is the list of all the dependencies. So all the OBJs will be included in this command. Minus O, dollar at is the target. So this will get replaced with my program. Now the pattern rule to convert star.c to star.o is CC, C flags minus C, dollar followed by a less than sign. If you remember, this is the first prerequisite or the first dependency in the dependency list, minus O followed by the target. Target is again um, my program. Oh, sorry. In this case, the target is the obj file name. Sorry. Some of the common commands. If you give make from the command line, it will build the default target. Default target generally is called by name all or your target name or in the list of targets in your make file. The first one is the default target. Generally, when you use make, the make file should start with the capital letter M and a make file. If you want to use a different make file, not the same as typically the make file name, then you can say make minus F and the file name. If you want to build a specific target, you can give the command as make target. If you want to just do a dry run, show commands without executing, you can say make space minus N. If you want to run multiple jobs, you can do make minus J4. In this example, it will run with 4 parallel jobs. If you have defined a target, generally you define a target clean, which will remove all the OBJs and the target. So you can run from the command line make clean, which will just clean up. It will remove all the OBJs, remove your target. So your folder becomes clean. So next time you run make, it will build all the files again. So we have covered the basics of Makefile. If you would like to explore more details of the Makefiles, you can refer to this online manual. I have given the link here. You can go here, or there are many tutorials online. You can search for Makefile tutorials, or you can explore Makefiles from common open source projects in GitHub. Uh, and also, what you should do is you should always try writing your own Makefile and compiling your code. That will give you a good feel of how Makefiles work. Thanks a lot. This is all for this tutorial. If you like these sessions, please comment and let me know what more you would want me to cover. I will cover those topics. And please subscribe and like this channel so that it reaches a wider audience. Thank you.